Welcome to today's lesson on managing transactions in MySQL. Understanding transactions is crucial for maintaining data integrity and consistency in your applications. In this lesson, we will explore what transactions are, how to manage them, and their importance in database operations. Don't worry if this feels new at first. This section covers what's a transaction. A transaction in SQL is a sequence of one or more operations that are executed as a single unit of work. A transaction can include operations like inserting, updating, or deleting records in a database. The key characteristic of a transaction is that it must be completed in its entirety or not at all. This is known as the ACID properties. First, atomicity ensures that all operations within a transaction are completed successfully. If any operation fails, the entire transaction is aborted. Also, consistency guarantees that a transaction takes the database from one valid state to another, maintaining all predefined rules. Also, isolation ensures that transactions are executed in isolation from one another, preventing concurrent transactions from affecting each other. Finally, durability guarantees that once a transaction is committed, the changes are permanent, even in case of a system failure. Now, managing transactions in MySQL. To manage transactions in MySQL, you primarily use the following commands. First, start transaction begins a new transaction. Also, commit saves all changes made during the transaction. Finally, rollback reverts all changes made during the transaction if an error occurs. Let's look at a practical example to understand how these commands work in a real-world scenario. Let's move on to example, transferring funds between accounts. Imagine you have a banking application where you need to transfer funds from one account to another. This operation involves two steps: deducting the amount from the first account and adding it to the second account. To ensure data integrity, we will use a transaction. See the example on this slide. Pause if you want to study the details. In this example, first, the transaction starts with start transaction. Also, we deduct $100 from account 12,345. Also, we add $100 to account 67,890. Finally, if both operations succeed, we commit the transaction, making the changes permanent. However, if an error occurs during either update, we would want to roll back the transaction to avoid leaving the accounts in an inconsistent state. Here's how you could implement that. I'll let you read the examples on screen rather than reading every line aloud. Next, importance of transactions. Transactions play a vital role in database management systems for several reasons. First, data integrity. Transactions ensure that all parts of an operation are completed successfully, maintaining data accuracy. Also, error management. They allow developers to handle errors gracefully by rolling back changes if something goes wrong. Finally, concurrency control. Transactions help manage simultaneous database operations, preventing conflicts and ensuring data consistency. In this lesson, we covered the concept of transactions in MySQL and their importance in maintaining data integrity. We learned how to manage transactions using the start transaction, commit, and rollback commands, and we explored a practical example of transferring funds between accounts. Go ahead and work through this exercise. First, write a transaction that transfers $50 from account 11,111 to account 22,222. Make sure to handle potential errors. Also, modify the transaction to include a check to ensure that the balance doesn't go negative. Finally, implement a transaction that involves 3 different updates to 3 different tables, e.g., accounts, transactions, logs, and ensure all operations succeed or fail together.